Hi, it's your math facilitator, Naomi Andrick, and I have a great little resource I wanted to share with you on solving linear equations in algebra. This is actually from the National Library of Virtual Manipulatives, which is a great little website that has all sorts of little hands-on things to do, but you don't actually have to have the hands-on things with you because they're on the computer. So you can see here we have a scale set up because an equation is like a scale. An equation sets two things equal to each other. It says these, represent the same amount. And a scale, if you have it balanced, you have two things that kind of weigh the same amount. So this is a great way to visualize these types of problems. Now, if I was going to do this, I'd put this 4x plus 3 on one side of the equals. The equals is like the middle of the scale. So 4x is just 4 x's. I can just drag and drop them. And then 3 more is 3 more little ones there. And you can see if I've added to one side and not the other side, it's not equal, right? It's not like this expression is equal to 0. It's equal to this other expression. So it's not going to be balanced until I add the other side. So here I added my 2 x's. Now I'm adding my 5. So I've got that. And this is a visualization of that problem. So if I continue with this exercise, it says, I know to solve, I'm trying to get an x by itself. So I've got x's on both sides. I think maybe if I was going to get just one x by itself, I'd take 2 x's from both sides. If I do the same thing on both sides, it keeps the balance balanced. So I would subtract 2x from both sides, and then it gives me a new equation, what I get if I subtract 2x from both sides. Then I see, oh, well, I've got these 1's over here, and I don't want them. I just want x's over on the left. Since I've got x's over the left, I just want x's over on the left. So now I might subtract 3 from both sides and see what happens. Take away 3 here, and also over here, so it stays balanced. And I end up with 2x equals 2. And from here you can probably, guess the answer. X is 1. If 2 x's is 2, x has to be 1. But technically what we're doing is we're dividing both sides by 2. So if I divide both sides by 2, I end up with just x equals 1, and that is the solution to this equation. Okay, so you can see how this might help you solve an equation. A lot of your checkpoint equations are a little harder than this, but after you simplify both sides, they get down to something like this. Okay, so let's see, before I go on, you can create your own equation here if you want to, and then walk through it with the visualization, even checkpoint problems or something like that. Okay, so let's do another problem. This has 3x plus 3 equals 2x plus 5, so I would just drag and drop everything there. And now that I've dragged and dropped everything, I can start taking the same thing off both sides. So if I continue, I'll see, let's see, there are more x's over here, so I might subtract 2x from both sides and just have 1x left over here. So I go minus 2x, 2, on both sides of my equation. It gives me a new equation. Now I don't want any 1's over here because I want x all by itself. So I would subtract 3 on both sides of the equation, and I end up with x equals 2, and then I'm finished with this problem. Well, I hope you check out this resource and try a few problems here. I think it's great practice, and it's a nice way to kind of see what's going on. Good luck. Thanks. Bye.